Good morning, everyone. Welcome to today's webinar, Revolutionizing ADA Compliance, Harnessing GIS for Streamlined Reporting, part of the Connect Me Asset Management events. GIS and AI for Local Government Compliance Reporting and Asset Management Series. I'm Tony Spicci, Executive Director of the GIS Certification Institute, and I'll be moderating today's event and hosting the Q&A later in the presentation. Before we get started, we'd like to run a quick poll of the audience to find out where you are from and what industry and sectors you work in. The poll should have popped up by now on your screen, and if it hasn't, please wait a minute and it will. But please be sure to fill out the poll and hit submit so we can get those results. Today's event is designed to be interactive, so please enter your questions into the QA space, which is located at the bottom of the navigation bar on your screen. There's no need to raise your hand. Just post all the questions in that Q&A space and we will get to them as appropriate. Presenters will also respond to all questions at the end of the presentation in a panel discussion at the very end of the session. So we are going to have a couple speakers. They're going to go through their sessions, and then when they're all done, we'll have that Q&A at the end. Also, please be sure to participate in any audience polls as they pop up. There's going to be a few of these throughout the event. For more information about our speakers and for the event agenda, click the Resources tab at the bottom of your screen. We also have shared some useful links in the Resources section, which you can click on at any time during this session. This event is being recorded and it will be available for download and on demand after the event. You're going to receive an email notifying you when the recording is available and how to go about receiving it and getting it. Before we start, we'd like to thank our webinar series sponsors, Carasoft and Bad Elf for making this educational opportunity available to you, and DeepWalk for sponsoring this particular session. Today's featured speakers include myself, as well as Dr. Nick Smilovsky, the Geospatial Solutions Director of Bad Elf, Phil Ponce, President of EMS, Brandon Yates, founder and CEO of DeepWalk Research, and Jerry Tippman, founder and CEO of Next Level Services. A little bit of a session overview. The complexity of ADA, or Americans with Disability Act, compliance requires accurate, timely reporting to ensure accessibility for all citizens. Local governments face significant challenges in meeting these regulatory requirements efficiently and effectively. In today's session, we're going to focus on how GIS tools can revolutionize compliance reporting for ADA requirements. We will also delve into the critical role that GIS technology plays in ensuring accurate data collection, efficient analysis, and effective communication of results to regulatory bodies. Hopefully, today, we'll be able to help you to understand the importance and benefits of GIS in ADA compliance, discover practical GIS tools and strategies to streamline reporting processes, gain insights from real-life case studies and expert experiences, and enhance your ability to meet regulatory requirements effectively and efficiently. So let's take a look at those poll results. Looks like a good percentage of our folks are from local government. Over 3/4 of the folks are local government folks, followed by state government. We have a few folks from federal government, academia, industry, and the always elusive other category. So welcome to all of you. We're glad you're here. Almost every one of our folks today is from the United States of America. We have one person from Europe, so welcome to you and welcome to all. Business sectors. We have a lot more diversity in this question. So about 1/4 of you are in land and public administrative or planning sectors and government. We have a good representation from transportation, a lot of folks in public works. And then we have folks scattered across a variety of different industries. And so it looks like we have a really good diverse population in this presentation. So we're very, very excited about that. Good representation from different size communities. Pretty well balanced, everywhere from under 25 to over 100,000 folks. So it looks like we've got a great crew, a very diverse crew. And like I said, we're very glad you're here. We've also got a great group of speakers. So let's go ahead and get started. I'm going to turn it over now to Nick Smilovsky, who's going to start the first presentation. And again, at the very end, we'll wrap it up with Q&A. Nick, take it away.
All right. Thanks, Tony. I'm going to go ahead and share my screen. And hopefully we don't have any technical difficulties. Again, thank you, Tony, for kicking our event off today. I'm going to be our first kind of presentation here. We're going to be discussing building on solid ground, geodetic foundations for ADA asset compliance. And so our whole presentation from Bad Elf today is going to be really focusing on the importance of having a strong geodetic or foundation to your ADA asset management. So let's go ahead and jump in. We'll quickly do an industry solutions poll to kind of see how everybody is feeling out there about the ADA world. We'll do that in a second. We're also going to continue Tony's quick discussion on why ADA compliance matters. We'll segue into why accuracy, specifically spatial accuracy, matters for ADA compliance. We'll talk just very shortly about Bad Elf GNSS powered solutions. Just truth be told, as the sponsor of the event, we got to get the bills paid, and so we got to make a quick plug for the solutions and enablement. So without further ado, I'm going to go ahead and pull up an industry solutions poll. If you would please take a second, fill out, are you currently implementing a GIS solution for ADA compliance? Are you interested in doing so? If you do have a solution, do you need to talk to somebody about potentially maximizing it? And then last but not least, we'd love to hear if you are currently using high accuracy GNSS, global navigation satellite systems, or GPS might be a more ubiquitous term you're familiar with, to currently collect assets. So that's going to be running for a minute. They'll shut the poll off here in about 30 seconds. And then when the results are compiled, it'll pop back up and we'll take a moment out of the presentation to look at that. So thank you for spilling the beans. So who is Bad Elf? If you've never heard of us, we've been around for about 15 years. We make high accuracy global positioning systems that connect into your smart device of choice, iOS, Android, Windows. We Bluetooth connect in something called the BYOD, bring your own device market. We specialize in affordable, accurate, and versatile GPS devices. We are an Esri Gold partner. We're also a GISCI endorsing company, and we're on GSA, so getting that all aside. But the important part here is, why are we all sitting here today on a Wednesday talking about ADA? Well, ADA, and it didn't surprise me if I back up even, Tony mentioned that there was only one international person here at this event, unlike previous events where we usually have a global audience. Well, the reason probably is that ADA is the American with Disabilities Act of 1990. It safeguards civil rights and mandates accessible infrastructure such as sidewalks and curb ramps here in the United States. Now, other countries around the world are going to have their own sets of standards, but ADA is specific to America, and it ensures equal sidewalk access, keeping all communities inclusive. So imagine that you're going down the street and you have to cross that street and there's a sidewalk. Maybe you are handicapped, perhaps that you are blind or in need of using a wheelchair. And so these are critical pieces of infrastructure that we need to have within compliance so that we can actively mitigate issues and that we can make inclusive environments for everybody in our communities. Okay, and so who regulates this stuff and enforces it? And this is important because right now the U.S. Department of Justice, so the DOJ, Title II for public entities, and the U.S. Department of Transportation, so the DOT, Fed DOT, they oversee the rules and ensure sidewalks and ramps get built right. And in fact, if you don't have You don't have your ADA transition plan in place, you can avoid and even not get funding. So I want to do a little mental math to so everybody can kind of understand how important ADA assets are for the public. And so in the United States, we roughly have about 4 million centerline miles of road. Currently, sidewalk coverage is estimated at about 40 to 60% of those roads. And one-sided sidewalks yield about 1.6 to 2.4 million sidewalk miles. Two-sided sidewalks yield about 3.2 to 4.8 million sidewalk miles. So a balanced estimate of about 2 to 5 million miles of sidewalk nationwide must be mapped and asset inventoried for ADA compliance. There it is. That up to 5 million miles of sidewalk that we need to be paying attention to. And here it is. These compliances aren't easy. We're not talking about like put it on a map, right? No, it can be a lot more complicated than that. We need to know slopes, and we need to know how the running slope and the cross slope and the widths and the direction and in terms of, say, even the push button, crosswalk buttons, you have to know the pressure involved. And so these are very precise accuracy requirements. If you're talking that a cross slope has to be under 2% grade, under 2% slope, that's a hard number to reach, right? And so if you're familiar with ADA, you've seen pictures like this and diagrams like this of different slopes and running slopes and cross slopes. But the point here I'm trying to make is this isn't super easy. This is a lot of data. There's a lot of stuff going on to properly capture these assets. And God forbid, if you are out of compliance, you could cause some serious injury, if not death, by having these things not be in compliance. And traditionally, ADA has been collected with all the traditional means, right? Literally levels. And by the way, about 7, 8 years ago, I did a fun study and I proved beyond reproach that a level on a sidewalk panel used 10 times by 10 different people on 10 different days will get you 10 different results. So traditional means were complicated. You had to do a lot of manual labor. You had to transcribe these things by paper and maybe wheels, right? And so we have to figure out a better way to do this. And the accuracy here is hard to get. It's also important to understand when we talk about accuracy, there's absolute accuracy, and then there's what we call precision. Absolute accuracy, aka where am I on the earth? So how accurate are you, like if I'm standing in the sidewalk panel to say a known location on the earth, versus if I'm looking at a sidewalk panel and I need to know the slope of the panel unto itself, its repeatability, its precision, how good are the data unto themselves within the data set? Those are kind of two different things. One tells you where the sidewalk is on the earth. The second one is able to tell you how accurate that slope is. This is a great diagram. On this axis here, you see absolute accuracy, and on this axis, relative accuracy. So down here in the lower left-hand quadrant, you have low absolute and low relative accuracy. Think about playing a game of darts and you're throwing the darts errantly all over. Or perhaps you have a very high accuracy here, or a better absolute accuracy, but it's not as tight. So the best solution is to have high accuracy and high relative accuracy. So not only is it positioned well on the earth, it's positioned well unto itself. So how do we do this? Well, Bad Elf creates a bunch of GPS devices or global navigation satellite systems that are able to go out and collect survey grade data. These data can be attached into your data collectors, your phones of choice, whether you're using field maps or DeepWalk, or there's a bunch of different apps out there, and we're going to hear later about how different people during this webinar are collecting data, right? The Bad Elf GPS, this thing here, it's just the device applying and supplying that high accuracy needed to meet your compliance regulations. And I'm going to sycophantically throw this out there that the Bad Elf Flex Mini Extreme can get 2 centimeters or better of accuracy now for only $1,500. There is no excuse ever to not go have a GPS attached to your device out in the field, right? And if you're part of the government, you even get a discount on top of that. You're talking, it's as much as a big iPad, right? And these devices no longer have to go on survey polls. They can be attached to phones and tablets. And again, I don't want to get ahead of some of our partners that will be talking here in a minute, but there's a lot of really cool ways to do this. I also mentioned quickly that Bad Elf, we've got an exclusive partnership with a company called Pix4D. Pix4D is a photogrammetry and LiDAR processing software company used a lot of the time for drone mapping. But in fact, they have some terrestrial-based systems, very similar to what you're going to see from Brandon later. But this type of technology utilizes GPS to provide the accuracy. So here's a quick video. Honestly, I just wanted to play that video so everybody would be awake after the music. But in the video, you saw a Bad Elf GPS attached to an iPad tablet being utilized here in San Antonio, Texas, for an ADA project. And so this is sort of that new way we do it. And so let me just break it down to you in very simple terms, okay? Bad Elf GNSS provides your data collector the accuracy and precision it needs to complete your ADA asset mapping project within compliance. We're affordable, accurate, and versatile. It's time to revolutionize your ADA compliance today. No longer should you be taking out paper and pens and pull tapes and levels. You should be taking out a GIS solution that can collect high accuracy data that is very repeatable, and it's going to be able to honestly stand up in a court of law, right? So how do you get there? Well, we can help you at Bad Elf. We do have an enablement team. Let us get you to zero to hero. We do all the custom trainings, no matter the app you're using with our devices. Additionally, we have an online learning management platform called an LMS that we've created for all of our first-time users and anybody that needs some refresher. And so our goal here is to make it as easy as possible for everybody. We do in-class trainings, integrations, whether you're a city like this is the city of Tempe, and we were training about 19 departments, or you're a very small entity and you just need help in a mom and pop shop, so to speak, we can do all of that as well. So before I wrap up, I'm out of time and they're pulling me off the stage. Can we go ahead and compile that industry poll? And I'll let everybody know just a little bit about how things are looking. So currently it stands that about 20% of everybody are currently implementing a GIS solution for ADA compliance. So frankly, that's a huge amount of greenfield, really. A lot of you can enter that digital age, the digital twin, digital delivery. Also interesting, I want to just say that it looks right now that only about 33% or 30% or so are using high accuracy GNSS or GPS to assist in your data collection procedures. And so I think, again, lots of opportunity there. Once you get it, accuracy, it can be very addictive. And so I just want to say thanks. If you have any questions, you can go to bad-elf.com. We're at all the major, geospatial conferences across the country. But I appreciate you coming today. So I'm going to go ahead and wrap my presentation up before they get angry at me. And I'm going to ask Phil Ponce, my good friend Phil, from Phoenix, Arizona, to come up on stage. And Phil and I go way back, so I can talk a little smack as he gets up here. But Phil owns a company called Engineering Mapping Solutions and has been in the industry, gosh, 30, 40 years, and really brings a pretty awesome game to the table. And there is Phil there. Phil, I've talked as much smack as I can about you, sir. Are you ready to roll?
I believe so.
All right. You're in good hands. Thanks, everybody.
Thanks, Nick. I always love following you because I have to live up to the smack you lay down. But thanks a lot. My name is Phil Ponce. I'm the Vice President of Engineering Mapping Solutions. And today we're going to talk a little bit about how we collect data ADA data in the field. We're going to touch on a little bit of the workflow, the analysis, and some closing thoughts to wrap it all up. Just real quickly about engineering mapping. We've been in business for, gosh, I get tired of doing the math. I think it looks like we're almost 30 years. We do nothing but GIS. With the emphasis, we started as emphasis on wet utilities, that's water, sewer, storm, and quickly migrated into just an asset collection company. So some of the things I'm going to show you today deal with collecting other assets than ADA, but the focus will be on the ADA stuff. We are ESRI developers and business partners. Our overarching goal is to build accurate GIS that's functional, scalable, cost efficient, and deployed using various web solutions, mainly around the ESRI world. So as we were thinking about how to do ADA collection, I want to share with you the issues that we were thinking about that guided us towards the solution we're going to talk about today. First of all, manual methods. Manual methods in the field, and you saw some of the things that Nick was talking about, literally people on their hands and knees measuring slopes. And in order to do that, you got to have fairly well-trained, qualified personnel. This was actually a slide that Nick had in his stack. And you can see, you start talking about cross slopes and side flares and the landings. And, aside from all the jargon, you got to know the specifications that will meet the ADA requirements. And that's just not somebody you pull off the street to do this kind of work. You've got all sorts of things to consider when it comes to ADA. These are just a few more things. And traditional methods have you entering handwritten information about photos you're taking in the field, and it can just be very cumbersome and labor intensive. So we were looking at other options, and certainly in this day and age, LiDAR is an option. So we started looking at LiDAR and discovered that the high-end LiDAR solutions are very cost prohibitive. The hardware is expensive. You have to expand your infrastructure to accommodate the large data sets. And the software, at the time we were doing this, was very expensive. Now, the great thing is software evolves, hardware evolves, and even since we started doing this, things have changed dramatically, just as Nick showed you in his presentation. The other thing that LiDAR does, for anybody that's worked with it, it produces huge data sets. And anytime you're dealing with data sets that can get up into the gigabytes, you're talking about slower workflows. They're cumbersome to use. You got to transfer them from one device to the next, and even one drive to the next, and it just compromises the workflows. So let me talk about our solution. The first and foremost thing that we think of when we're doing this type of work, and not just ADA, but any field collection, is move the heavy lifting to the office. So we want to focus the heavy lifting to the office rather than the field. And I mentioned that. And the beauty of this, then, it relieves the necessity to have the top dollar personnel in the field. And we focus on collecting raw data in an efficient and cost-effective manner. We talked about the high cost of the LiDAR equipment. The beauty of what's happening now is we can leverage cell phone technology. And for those of you who don't know it, we can actually collect LiDAR point clouds. I don't know if you can do it with Android. We use iOS. And even though it's not as accurate as the high-end software or the high-end hardware, for what we're doing and what Brandon's going to show you at DeepWalk, it's every bit as accurate. We use our GoPro camera technology, and the resolution on these cameras is great. It's cost effective. And of course, we use the latest GIS mapping and collaboration technology. This would include ESRI Arc Pro, open source QGIS with Python. Let me turn my phone off. This is getting annoying. Custom widget or custom Windows-based tools, ArcGIS Online with Enterprise. Of course, field maps with ArcGIS and or ESR Quick Capture for anybody that's familiar with that technology. It's very efficient in the field. And of course, I couldn't go more than a slide or two before mentioning the Bad Elf Flex. So let me introduce you to Bike Rack. This is our e-bike rapid asset collection. And there you have it. It's an e-bike with a Bad Elf Flex unit strapped to the front. And if you could see very closely, we have the GoPro 360 camera up there. I also want to point out something that's kind of cool. For those of you that are familiar with Bad Elf, they have a rather cool approach to marketing with their cartoons. And I was lucky enough to be immortalized on the by the Bad Elf cartoonist. I think that looks like me. I'm not sure. I was patterned after me, but that's kind of cool. We have that. Let's talk about the e-bike. You get 8 to 10 hours range, and I can tell you from experience, that's way more than you need. Your legs hurt, your butt hurts. 8 to 10 hours is way more than enough. We're using the Bad Elf Flex to get sub-centimeter accuracy, which is very nice in the field. One of the things Nick says that's kind of cool is why would you do without it? If you can get it, why live without it? We leverage several Windows-based custom solutions that we leverage here. You can see that we have the iPhone here for scanning. We have a Windows-based device here on the front that helps us with our custom mapping. And we leverage either field map with custom configurations or quick capture technology. So yeah, we get 8 hours on the bike with the GoPro imagery. And so that kind of looks like me, that elf. That's me right there. This, I don't expect you to read through this. This is just something, one of our jobs we did back in 2020 that shows the amount of field work versus what was collected. We averaged about 80 points an hour, 80 high accurate GPS survey points, sub-centimeter per hour. And you could do the math. That's running pretty good. This is an actual GoPro 360-degree image coming off of the cameras. It looks a little funky here because it's wrapped around, but this is when you look at it on the correct viewer, it looks every bit as cool and flexible as say Google Street View. So, how do we approach solving the problem?
Provides interactive panoramic views from various locations.
I don't know if that happens to you, but my phone thought I was asking it a question and it started answering. So we settled on software that there's a couple softwares we considered. One was 3D Scanner and one was Scaniverse for the iPhone. And you can certainly Google either one of those. Let me save you the trouble. Scaniverse is a free app that does 3D models and leveraging the smartphone's LiDAR sensor. And so probably the first thing that jumped out at you, if not you, I think it's free. So that's kind of cool. The entry into this technology is very nice and affordable. So once you get your Scaniverse going, you get your scan on, and what you're looking at here is a scan that I created using Scaniverse, and I'm interrogating it in Cloud Compare. And once again, let me just show you, Cloud Compare is free. That's good, open source, and we use it to process the 3D point clouds. So what I did is you can see the lines that I've drawn here on the ramp, and scanned it so that when we do measurements, I could cross-verify against the actual measurements we did in the field. So just to get a sense of how accurate things are, and let's just see that the one thing is it's really nice that Scaniverse gives you an RGB image like we show here. But if you zoom in, here's where the rubber meets the road. Those are the LiDAR points that have XYZ on them that we can use to do our analysis. So that's pretty cool. But so let's see how we did. I told you I drew lines, and I've got the names here: the left approach, top, mid, bottom, and I kind of measured it all out. And it's not so much to look at these numbers. Brandon in the next presentation can talk to you about accuracy. What's important is I brought this data into QGIS and analyzed the point cloud and did measurements, because at the end of the day, you could see here, we have the X, Y, and Z. And so I wrote some Python custom tools in QGIS to allow us to pick two different points in space. And that's how I got these measurements that you see up here in the as we compared the results. So that's really where the rubber meets the road. That's how we do our collection. Let me just show you real quick some of the results. You can see here, this is a little test area we did in Chandler. We were collecting ramps and sidewalk. But not only that, we're collecting all sorts of information, including curb and gutter and the paint striping and all this other roadside features. Anything that you could see in the photos, we collect. So there's an example of an image that we collect. And you'll notice we have a front image on the bike. We also have a back image, and you can zoom very tight on this. So if you're doing any assessment whatsoever as to the quality of the sidewalk, you have plenty of resolution to accommodate what you're trying to do. Here's a same type of picture, only this is a ramp. So let me bring this to closure, because I've lost track of time since I don't know where how far deep into it before I started the slides. But let me just close with these conclusions. The first thing that I want to re-emphasize is we focus on field collection, getting the raw data, leverage the office for building the data. Secondly, we leverage the hardware that best fits your budget. And in our case, cell phones and GoPro, and of course the bad elf technology, all well within reason. So the last thing I'll leave you with is what I like to say is stay in your lane. Do what you do best and hire the expertise that focus on vertical markets. Nick and I have been working together forever. We have common clients. We've built a relationship over the years that just benefits us both. This is a perfect segue into our next presenter, because I just met Brandon last week, and he and I met remotely yesterday, I think, or maybe Monday, and I'm looking forward to working with him as well. So with that, let me introduce to you the founder of DeepWalk, Brandon Yates.
Well, hi, everybody. My name is Brandon Yates, and I'm one of the co-founders of DeepWalk. And our goal is to make ADA compliance simpler for municipalities, universities, DOTs, and the consultants that work with them. So the basic ADA requirements are, if your organization has more than 50 employees, including part-time, and receives state funding, they're required to create and maintain a transition plan. And a big part of this transition planning requirement is the self-evaluation. So you're required to inspect your sidewalk system, use that information to identify issues, and then create a plan to address the issues that you found. And then if you don't do that, you're open to lawsuits from local citizens and then also the Department of Justice. And a huge part of a huge challenge in ADA transition planning and self-evaluation is this manual inspection process, where we've all talked about how challenging it is. But one thing that's overlooked quite often is all the different steps. So yes, checking the slopes and widths and areas and different things like that are slow, but also planning for your data collection, training your data collectors, and then once you have all that information, trying to make it useful, make it easy to update, make it possible to get into budgets, compile it into your ADA transition plan, and then most importantly, create bid documents to go and fix the issues that you found. And that's what inspired our company. We got started in 2021 to exist, is when you collect the data by hand, typically you end up with either a digital or a paper checklist. And it's very hard to go from a checklist into a curb ramp retrofit program or a trip hazard removal program or vegetation removal or remove and replace. There's just a disconnect there. So you end up having to go and collect the data again to implement your program. So we built a mobile application that uses the 3D scanners on the iPhones, where you scan sidewalks and curb ramps. It makes a 3D model, checks all the slopes and widths and areas and deterioration and things like that, and puts that information on our web application where you can, look at the dashboards and different maps to identify your priorities, and then actually go and create programs and work orders to fix the issues that you found. So this is what it looks like. You just point at the sidewalk and scan it. We're getting about 1.5 miles per hour when you do the sidewalks and the curb ramps. And most importantly, it requires very, very little training. We have a 20-minute training on our website, and most of our data collectors are interns or people who just wanted to take a break and go outside. So while you're scanning, our system makes these 3D models, and we use machine learning to cut out the panels, identify what types of panels they are, the path of travel through the panels, the detectable warnings, deterioration, all that good stuff. And then it goes to our web application where you can track your data collection, you can create those programs, do your long-term sidewalk planning, and most importantly, we have a very robust ArcGIS integration where you click a button, log in with ArcGIS Online, and it copies all of our data into ArcGIS Online and pre-formats it for you. We're in over 90 municipalities across the country, and we've been able to serve the entire spectrum of municipality size. Our smallest customer has a half-mile sidewalk and a population of 400, and our largest customers are Louisiana Department of Transportation and Spokane, Washington. We also work with over 20 engineering firms that offer DeepWalk as a service. And a very common question we get is like, okay, we still have to walk it. How fast does this go? So about 1.5 miles per hour per person. And something to consider is it's so easy to train people that we can scale data collection up and down very easily. So very often, we'll work with a municipality and they'll have 5 interns out collecting, getting 40 to 50 miles a day. You can also collect with 3 different general project formats. So you can use your internal staff to do the data collection. You can partner with us and we'll actually send out data collectors to collect that information for you. And we also work with our different engineering firm partners, and they'll offer a complete transition planning service. And if you're curious, you can go to our website. There's a 20-minute online training that'll show you exactly how to do it. As far as accuracy goes, we outperform putting the smart level down 2 times on every panel, and we don't do post-construction validation. We're very specifically used for sidewalk planning, ADA transition plans, work order generation, things like that. So if you're installing a brand new curb ramp, your construction inspectors, their jobs are safe. So we also have a custom manual tagging system where you can go and add different fields that we don't automatically collect and just tag those yourself while you're in the field. So there's a crosshair in the middle of the iPhone app, and you press a button, shoots a tag, and it records it in the system. And I'm going to jump into some case studies that are pretty interesting. Genoa, Illinois is one of my favorites because they're a relatively small community and they don't have any GIS people. So they need to be able to manage their sidewalk programs without having GIS expertise on their end. So this is an example of a trip hazard removal program that they created with DeepWalk. So here's all the trip hazards that were identified in the system. They went through, you can filter by severity. So here's the big ones. Say we're going to go and make work orders for this area, select them out. We've got them all listed here. Here's a picture of them. And then you can go through call it your trip hazard remove and replace program for 20 whatever this year. And then it brings you to this screen where you can quickly review all the trip hazards that were identified. So make sure they're actually things you want to remove. And then you can either export it or just save it as a dashboard within our platform, where you can export it as different file types later. Maybe move it to Esri, move it to whatever asset management platform that you currently use, or you can always just put it in Excel and print it out. So yeah, Genoa, Illinois uses this for their trip hazard removal programs every year. And then they're also working on a remove and replace program and a vegetation removal program. Here's a new feature that we just launched a couple weeks ago, focused on curb ramp retrofit programs. So this is all your curb ramps. You can select those and filter, say we're doing a resurfacing program along the street. You name that, and then it'll pull up the top-down view of each one of these curb ramps, and you can actually take a look at the slopes on every single panel and determine whether you want to add this to your retrofit program. And you can use your engineering judgment while you're going through here and determine whether they meet the criteria of, replacement for your specific project. It's great for scoping. So you flip through all your curb ramps, and once you're done, it goes to your program list where you can go through and export that as Excel, GeoJSON, or other formats. So that's a good way to, make all your ramp programs. Say most curb ramps are replaced along with other projects. So this allows you to do that very easily. Another reason why we like Genoa is, they put all of our information on their website and kind of brag about all of the, sidewalk work that they're doing, and it makes the citizens, the locals happy. And then if the Department of Justice comes and asks what they're doing for their sidewalks, they just send them a link. So they're just doing a great job. We have two pricing models. So we've seen the most success when communities do a small amount of data collection every year. And we have a subscription model to support that. So you can get a 15-mile a year package or 20 or whatever. It allows them to not get overwhelmed with the amount of data they have. The cost is relatively low. And when they find issues, they can actually right away make a plan to fix it. We also have a per mile pricing model. So if you just let us know how many miles you have, we'll let you know how much it costs. So we have a rental program that's pretty popular. About half of our customers use it for the iPhones. And we're on the App Store. You can just download it and go if you would like. But a lot of our communities don't have access to the newer iPhones that have the LiDAR on it, and they don't want to deal with IT. So you can rent those directly through us. It's highly scalable, so we can send you 10 phones next week if you want. And we bill per week. And then we also have GPS units that we rent out, and we recently switched over to the Bad Elf units. I'm a huge fan. They're great for dense urban areas and wooded areas where the iPhone GPS by itself performs relatively poorly. The iPhone GPS is great, when you're out in the suburbs somewhere, it's wide open. But in downtown Chicago, where we're based, you need one of these units to get good GPS lines. Best ways to get started is we have a pilot program. It's discounted for anyone who attended this webinar. So just let us know that's where you found us. You can also shoot us an email or fill out a form on our website if you want a quote. And that can be for the per mile quotes or the subscription quotes. So that's a quick run through of DeepWalk and what we do. I'm excited for the Q&A afterwards. We've bumped into a lot of communities that are doing ADA work, so I'm excited to share what we've learned along the way. And now I'm going to hand off the presentation to Jerry Tippman, and he's an expert on actually fixing all the issues that me and the other presenters help you find. So excited to watch that. Thank you, everybody.
Hello, my name is Jerry Tippman. I'm with Next Level Services. We're a concrete leveling company. We specialize in the issues of trip hazards a lot, grinding, foam jacking, mud jacking, even into helical piering for structural lifting and that sort of thing. We do everything from residential to commercial, municipal, industrial, and when it comes to trip hazard removal and ADA compliance, that's a big section of our work. As far as yeah, as far as ADA trip hazard goes, probably about 5 years. I think it was about 5 years ago we started using a GIS program. Again, we are a concrete leveling company and tend to be technologically impaired on some of the stuff. So, we're not an IT specialized company. So we got into some GIS stuff that was kind of above our realm. After that, we got a hold of um, referred to a company called Bad Elf. Um, we got a hold of Bad Elf, a little skeptical when we first heard about them because Googling the word Bad Elf was questionable, but we got a hold of the gentleman at Bad Elf, and they were able to hook us up with a system that worked really well for us. We were able to go out and start mapping areas so there was no confusion between the estimators, our customers, and it even went into as far as like when we would do there's one big one that we talk about a lot, an edition called Arlington. Um, the HOA had us mark trip hazards for their edition, and it was, I think we got into like 860 when all was said and done. And the HOA that had us look at it had gotten several bids from other contractors that were all over the board. It was contractors saying, I think one of them was as low as 100 trip hazards. Another one said, if we get into the 2000 location mark, but nobody had an exact number where we were able to come into this with an exact number, the exact location, so the HOA could see the areas that were being hit. If there was anything that needed addressed that we had missed, a homeowner calls about an issue in front of their house, we can add that to the map. We were able to give an exact price with an exact amount and fit it into their budget, similar to a government where you're allotted X amount per year for their trip hazard program. And we were able to break it down into a 5-year program where we hit X amount per year, left some contingency in there for if anybody called about, a certain section, a curb or something like that needed addressed that was above that mark, then we could still get it taken care of under budget for that year. So that was Bad Elf was the one that we have their unit here, if you can see that. We started using that, and again, being a concrete leveling company and not a technology company, it was great. We were able to learn it easily, be competent in it, and then I'm going to, again, going back on our technology issues here, I'm going to share a screenshot of our view of the way we present it to our customers, and I'm going to use the Arlington example once I get that pulled up here. All right, so what we did is we went out and mapped this area, and then it overlaid into, it came up as KML file. We were able to pass it along to, or email it to the association. The board members were able to open it in their meeting very easily. And when they download it, it gives the option to open with Google Earth. And we were able to see, so we could mark out exactly the trip hazards, the areas that we were doing, the sections that were beyond repair that needed removed and replaced, what was getting grinding versus lifting. And that way they knew this was for the private walks of the addition. We also do the streets for the city, but this was strictly the private walks behind the houses and the golf course and that sort of thing. And we were able to go in I was just learning the program at the time, so we used a low accuracy. We had the option to use higher. I was just learning it and I guess being impatient too with it. So we were able to go right in and see. We use there's an area here called Rocket Hill that we were able to see, and you can actually see on Google Earth here the areas that we had already removed and replaced versus the sections that needed lifting and or grinding, and then sections that had yet to be removed and replaced. I'm gonna back out of the screen. So yeah, that was so that was a very good tool for us. We have our own way of going in and checking 1/4 inch is ADA standard for trip hazards. 1/2 inch if it's a beveled edge. We really run into beveled edge, go off 1/4 inch most of the time. And then you have the 2% or yeah, excuse me, the 2% slope that we run into with that and mapping truncated dome areas where they have the ADA mats. One of the things that we've ran into with that and we're starting to do is when truncated domes are placed, when concrete's poured, the three common ways of doing it are stamping in, and if so you're familiar with what I'm talking about when I say truncated domes, it's the red mats that have the beads that kind of stick up. The ways of doing that is when the concrete is poured, there's an actual mat that you can set in while the concrete's setting up, and it has bolts. So if that after it cures, if that has to be removed or replaced due to damage from like a snowplow or something like that, it can be pulled off and replaced. But what was happening was the truncated dome mats were not allowing the concrete off gas and cure properly, so it would they would fall apart a little bit underneath depending on when they were put in and how they were put in. Kind of have like a sandy, gravelly texture underneath. So a lot of those were needing replaced. We were able to go out and map where those needed to be replaced. Um, Another thing that we've used the mapping systems for is we work a lot with property management companies, marking. We do signs, stop signs, um, ADA parking stalls when we're looking at the 1:26 ratios and for parking areas and how many have to be van accessible and that sort of thing. We can mark if something needs addressed or updated, and then use that to some of the shopping centers we deal with are very large shopping centers, so it keeps the customer in line where they can go out and look at it, see what needs. Um, One of the big things is providing that exact amount to the city of Fort Wayne is one that we deal with a lot. And it's the right-of-way department is one that we deal with a lot. The street department, bridge department, Fort Wayne Community Schools, as well as the Parks and Rec department. And we've been able to utilize the mapping software to where everybody's on the same page. A lot of times, a right-of-way department or a city will give us addresses, and it could be, a section of road. They'll give us, crossroads, and we're trying to hit a section of sidewalk within um, a 1 block area. But a lot of times there's something that needs done right around the corner where there's a tree that's lifted a panel of concrete that we have to lift the adjacent panels, and we can mark out that was done. So they know if they have that in their file that the address next door had a place that need hit, they can see that. It just eliminates a lot of miscommunication between crews in the field, estimators, customers, and then when we get into the HOAs and stuff like that, the residents oftentimes have a lot to say when they call the HOA and kind of see what needs done, what needs addressed. Um, as far as that goes, like I said, we do a lot of our main forte is one of the things Phil talked about when he used the word heavy lifting. I kind of giggled. That's what we do, is the heavy lifting, and being able to utilize that as a leveling company where everybody's on the same page and use that mapping has been very beneficial to us. The cities that we've used it with, again, City of Fort Wayne, City of New Haven, they've been has been very beneficial to everybody, where it's not just giving out addresses now. And then the IT department has, for the municipality has stuff mapped out and stuff like that, but it is no, um, I guess, comprehensible to guys in the field and communicated well when it's mapped out that way. And then just random addresses, um, a lot of things fall through the crack. We're able to smooth that and eliminate anything missed. So it's been a great program for us. Um, I highly recommend using, if you have concrete leveling companies in your municipality that use this software or this technology. It keeps everybody on the same page and eliminates a lot of possible problems, communications gap, that sort of thing. So that's about all I had. I'm going to open it back up, bring the other presenters up on stage. And I believe go to a question and answer session after that. So if everybody wants to come back on, you're more than welcome.
Thanks, everyone. We just heard 4 great presentations, and now we're going to open it up to Q&A. So we do have a couple questions already in the queue, but if you have any more, go ahead and add them, and we will get to them. And so let's start with Nick. And Nick, our first question is, what happens if you do not have an ADA transition plan?
Yeah, so I can at least start. I'm not going to claim to be an expert. I might ask Brandon to jump in a little bit. But what I can tell you from experience is a lot of funding is tied to having an ADA transition plan. So that transition plan being, kind of what did you have previous, like not really paying attention to ADA, and then what's your plan to get everything up to compliance? And if you don't do those things set out by the goals in that, you could say lose federal funding for highways and such. But Brandon, maybe you want to jump in and, I know there's more nuance to it than that.
Yeah, I can jump in on just a couple enforcement mechanisms that you typically see. And again, I'm not a lawyer, ask a lawyer.
Yeah, me either. So,
Yeah. But one enforcement mechanism is Project Civic Access through the Department of Justice. So they do audits that are usually triggered by a complaint. And if they come knocking on your door, essentially you get like an accelerated, very heavily monitored transition plan requirement. So that's typically how those go. There's also organizations of people with this that represent people with disabilities, and they will get together and ask for a transition plan. If you don't have one, there's lawsuits involved with that. So you can look at like New York or Pekin, Illinois, if you're looking for a small municipality that had tough go at it with that. This is also leans up with trip and fall as well, to where it's like it can be helpful when if you get a trip and fall claim, you can ask, or you can say, essentially, we have this way for you to complain, and we had that scheduled for next year. This is our policy that's on our website. If you would have complained, we could have accelerated that. So those are like some of the common approaches. And then different state departments of transportation are really stepping up both support and enforcement. They're starting with support, but you'll see a lot of emphasis in like Oregon and Washington. California is super weird. Texas has some sort of deadline that I don't know how hardcore they are with that one. And then Illinois is trying to figure out where they are and then support communities and getting that put together. So there's a lot of different enforcement mechanisms, but the deadline was technically 1992. So the time defense has ran out.
Bill, Jerry, do you have anything to add?
No, I think they hit it pretty good. I think it was very well said, and I don't know. How about you, Phil?
No, I'm good.
Okay. Phil, question for you. You referenced a 360 camera. Is that used just for visualization or can be used for other things?
So that it's a great question, and what I can do is I Googled a couple things on this answer, and before I tell you what I Googled, the the key is that the images that the GoPro collects are, in essence, GeoTIFF images. And what that means is it has metadata buried inside of the image that tells us the camera it used, the date, orientation. It tells you all sorts of things, including coordinates. Now, unfortunately, it's using the GPS unit embedded in the camera, which isn't as good. So what we do is we synchronize the UTC time that the bad elf gives us with the UTC time that the camera thinks it is, and it's very important. And you'll want to Google GoPro calibration UTC, and that'll give you a little direction on what you need to do to your GoPro camera. It involves installing the GoPro Labs software, but what that allows you to do is synchronize your camera to the UTC time. That's a universal time, and the bad elf is already calibrated to that time. So when you collect a photo, you synchronize it to the exact UTC moment that the bad elf collected its data, and now you have a centimeter accurate location for your photo. It's a lot deeper than that, and I'd be happy to share you more details. We didn't trip across this very easily, but it's the gold that makes GoPro work with the bad elf.
Okay, and so the GoPro itself doesn't have GPS coordinate collection features, correct?
It actually does. It buries it in the GeoTIFF. It's just that the GoPro was, I think, started for surfers and skiers, and they didn't necessarily care where they were. So we're kind of using this for our technology, which requires accuracy. So as engineer geeks that are cheap, I always try to find the best, easiest solution, and that's what we found. But as anybody that took the time to attend this webinar, I would be more than happy to share our insight on how we did this in more detail, probably more detail than we can do here.
Okay, so that sounds like a great follow-up. Nick, I'm going to start with you, but I'm going to open it up to everyone on the panel to answer this question. But you mentioned that traditional ADA compliant measurement methods using levels produce inconsistent results. So can you elaborate on the specific challenges you've encountered in your study that demonstrate the variability in manual slope measurements and how high accuracy GNSS technology directly addresses those inconsistencies?
Yeah, absolutely. So I was actually referencing, maybe it was about 7 or 8 years ago, I was on a team that did the ADA transition plan for the city of Tucson. So about, I don't know, 3,500, 4,000 miles of data collection. So we had to figure out a way to do that quickly, affordably, cheaply. And, this was before my time at Bad Elf, frankly. When we were looking at trying to go after this RFP, we were looking at large vehicle mounted LiDAR systems at the time. And so think like Google trucks driving down the street. And so that's what we had. And we had to prove out that these laser systems could collect the measurements that would be highly accurate, comparatively to traditional methods. And so what we found is when you take a digital level, and you literally go to your kitchen table, okay? You think your kitchen table's flat, it ain't flat. But go and sit at your kitchen table, take the digital level and put it on your table in 10 different locations. You're going to get 10 absolutely different results. And it's almost shocking how unlevel things can be. And then we had to kind of correlate that to laser scanning. And what we were able to prove is that with those laser scans, we were able to shrink the cross section down and take a single layer of laser, and the repeatability, the precision of those 2 points on the curb, 99% of the time was more accurate and repeatable than somebody going out to that same panel and laying down a digital level. So my point was, in which we were able to prove we won the jobs, and it led to other work. And actually, Phil and I, we were done another story for another day, but we were able to show that, in fact, the repeatability of something that uses scanning technologies is going to be more repeatable than anything with a level. Now, I'm going to refer back to Brandon here because we were chatting off stage. Brandon's got a really neat study that actually quantifies this, and it's not me just waxing poetic about it. Brandon, you want to talk about that study quickly? Maybe share it.
Yeah. So I didn't do the study, which is good. So Oregon's Department of Transportation and I think Oregon State University collaborated and did like a really robust study on the repeatability of inspecting curb ramps with digital levels. And they broke it down by variable of, how much does the angle affect, the measurement. And they had 100 something inspectors go out and measure the same ramp, and they quantified, everybody's measurements and the variability between that. Um, I don't want to butcher it, but it's a really interesting study that I think will be shared. Yeah, looks like it was shared. That's worth reading if you really want to dive into the weeds. But what's really surprising was the standard deviations that they got on the slope measurements. I think the initial one was over 1% standard deviation, and then they did some outlier removal and got it around to like 0.56% slope as the standard deviation, which is really high when people are tearing out ramps for being 0.1, 0.2 over. So it's just an interesting study. It's worth a skim, and I think they did a really great job.
And I guess really quick, just to circle back, and Brandon, I'm downloading that study as we speak. The GPS, right? That the global positioning system behind the scenes, say helping DeepWalk or Phil's system, what it's doing is that because it's a higher accuracy device and it's providing a highly repeatable measurement, even if the measurement is slightly off, remember my little X and Y scale of absolute versus relative? Even if the absolute accuracy is slightly off, but the relative stays tight, the GPS even has the ability to be able to collect the delta there. Now, I will mention that shooting GPS for sidewalk slope measurements can be very dangerous. And I just want to throw that out there. And what I like is when you couple the GPS with some type of scanning or reality capture device, whether it's photogrammetry or LiDAR or whatever that thing may be. I think that's the sweet spot. What Jerry was talking about, though, like going out and relocating trip hazards, and if you're trying to do identification and mitigation of, the GPS is going to be great. So there's a little bit of nuance here, but at the end of the day, these higher end technologies, they're just more repeatable than people. I hate to say that. So all the AI overlords that are listening in, don't come to my house first when you take over. I'm being polite. It just the tech does better.
Great, thanks. And back to Phil on the 360 camera. What kind of applications work with that 360 camera on the smartphone? Is it more than just one?
Well, the world that I run around in is more on the desktop world with ESRI software. And one of the things that I put in the answer is ESRI software refers to 360-degree imagery as oriented imagery. So if you were to Google ESRI oriented imagery, I put that in the answer, you'll see how ESRI thinks of the way to use this imagery. We love it. I mean, you can certainly you capture this imagery, but you need to view it with a special application. And ESRI has oriented imagery. I have another thing that I call photosphere in the JavaScript world, and I bury that in my applications. And you can use those on mobile phones, no problem. A great little example. It's a little morbid, but there was a cemetery here in the Phoenix area in Carefree that wanted to know where all of their where the bodies were buried, for lack of a better term. They used ground penetrating radar to locate the caskets and drew a line. But in order to make a map, we had the option to do a drone. But what we did is we walked up and down in a grid pattern using the 360 camera, and then we presented it in Experience Builder web-based app. So I guess that's a long answer, Carrie, to your question, but there's a lot of different ways you can leverage that 360-degree photography.
Great. Thanks, Phil. Here's a question for all of the panelists to answer. Can any of the speakers or panelists give context to costs? For example, if I need to assess 200 miles of sidewalks or ramps, what might that cost be for the process data?
I can start. I just ran a quote after I saw that question. And we are, where to go? It's $411 dollars per mile for the sidewalk and curb ramp inspection on our end. It's about a little less than half that if you're only doing the mid-block sidewalk, so if you're not doing the ramp analysis. And then I didn't run the ramp only pricing, but it's significantly cheaper if you do a annual subscription. So our 25-mile a year subscription that includes like the web platform and up to 25 miles of scanning a year is 12,000 a year for that option. So those are just some snapshots. Our pricing gets down for the sidewalk and curb ramp as low as 200 per mile for large projects. And then it kind of caps out at about 500 for smaller projects.
And I think what's interesting with what Brandon's talking about is DeepWalk has a very unique system and solution. It's a complete, holistic package. If you need to go out there, as Brandon showed, where, that's an all-in price with the tech and the app, and it does the things, right? And if you were to look more like maybe at Jerry or Phil, they are, I don't want to say Frankensteining because that sounds negative maybe, but they are using different technologies together, whether it's Google Earth and a GPS or a GoPro and a GPS and Esri. They're putting different disparate technologies together. And so the price can wildly vary. I mean, that's the reality of it. But if you can start imagining in a traditional sense, you would have to send a survey person or some type of technician out there to collect the data manually. You've got the actual walking and the processing, the entry of the data. So I think it's highly variable depending on what kind of systems you're using. I mean, I don't know if Jerry or Phil, you would agree.
Let me add to that, Nick, and it's kind of indicative of why we did this web seminar in the first place. People like you and I are on the front end, Brandon's on the collection end, Jerry comes and fixes everything that we find. And so while Brandon says that's get a price for collection, you really need to consider the front end and the back end in the whole thing. And it's real hard to give, especially for my part, $1 per mile. But Brandon's technology works out great. For my part, Nick, I'm gonna look forward to using Brandon's technology for all my clients that need that type of work. And that's just, and I closed up with the slide that says stay in your lane. I tried to collect data. I think what I learned is somebody like DeepWalk really knows what they're doing, and I'd much rather pay them to do it than try to continue to slog on like I'm doing.
Yeah, and I appreciate that, but we see a lot of value from having a consultant at the end, in particular, to help you get that last mile. Because at the end of the day, we're a software company. We do what works for the middle 90%, of the universe, and you need to take into account your existing systems and your local communities and priorities, and that's where bringing in a consultant to really kind of refine that can be really helpful. Um, so, but yeah,
So Brandon, I think you agree. It's you're in your lane, we're in our lane, and it's the collaborative effort of all of us that make a solution for the clients.
yeah, our motto is we don't go outside. We're a software. Yeah.
I just throw this. Oh, go ahead, Jerry. Jerry.
Yeah, I was gonna interject real quick on something that Brandon said when you had asked about the cost, and you said it was about $411 per mile. Did that sound right?
Yeah, if you're doing the sidewalk and the curb ramps.
Okay, so I put those numbers in. We recently did an 8 mile map of an area, and the mapping for us to go out and map it was $3,500, and we thought that was pretty aggressively priced. And I just did 8 miles at 411 a mile is still a couple $100 cheaper than, I mean, that's 3,288. So in the ballpark, but more accurate and cost effective compared to what we were doing. So,
But don't worry, Jerry, you're better looking. So I'm just
right. Yeah.
He's got more hair
Appreciate that,
though.
Nick. But still, we were able to get out there, get it done, and it was, within a good realm, a good price, neck and neck on price on that there. So,
Well, Jerry, just to add to that, I that's what I discovered too in talking with Brandon a couple days ago was, oh my gosh, I can get I can get the feet on the ground. That's no problem. But to just simply collect and pay DeepWalk to get the answers, and then I bring those answers into my software. My gosh, what a perfect solution for the clients. And the monies and the fees are right. And we should not make this about us getting together here. Let's turn it back to Tony and the.
Yeah, so we have one last question, unless anybody has others. And if you do have any others, please put them in the chat. Going back to you, Nick, has any of the work that you've been done used in conjunction with a settlement agreement for ADA compliance?
Unfortunately, just due to the liability, I wouldn't feel comfortable answering that question one way or another. But just know that survey instrumentation are utilized every day, if not every hour, in litigated battles. And this is I like Phil's "stay in your lane" and that statement where like, if you're a PE or a registered land surveyor, like you need to have professionals involved in your organization to mitigate that liability. And so, like our GPS inherently collect a ton of metadata behind the scenes. And having some of those metadata compiled with an expert can help mitigate that settlement agreement or lawsuit. So I don't want to specifically say yes or no, but just know that that's what technology is going to be used for. So
Okay, and then,
I can
oh, sorry, go
interject
ahead.
on that. When it comes to, you use the word settlement there, a customer brought this to our attention at one point, because they had a settlement issue with the section of sidewalk. We went out and repaired it after the fact, and they had it was kind of a sales pitch that we ended up using after they told us, but they said that the thing was getting that those trip hazards repaired. They had us do a lot more for them after the fact, a lot more properties. And they said it's a lot. They said whether you get it done before somebody falls and hurts themselves or after, either way, you have to get it done. If somebody falls and hurts themselves and there's a settlement, you still have to get it done. It's a lot cheaper to do it before and be proactive than it is to miss something. So,
Anyone else? Okay, one last, looks like we have one last quick question. Um, Brandon, can you please repeat the cost per mile for the DeepWalk product that you were referencing?
Yeah, so the range is $200 to $500 per mile for the sidewalk and the curb ramp inspections, and then there's a small hosting fee too. Um, so that depends on volume. So Our 200-mile quote had it at $411 per mile doing the sidewalks and the curb ramps. And then it's in the universe of half that to just do the mid blocks without the curb ramps. And then we also have per corner pricing or per location pricing for ramps. There's a You'll get a follow-up email from us most likely, and we'll get you a quote. Just respond to that email, which is hey, I've got 176 miles or something, and we'll respond with a quote.
Okay, great. Well, I don't see any other questions, so I'd like to take a few moments to thank our four panelists and express our appreciation for them being here today. You will get an email with some follow-up, and we'll provide the link of the recording of this when it's available. So thank you very much for taking your time to be here. We really appreciate seeing you, and we hope to see you at another one of these seminars down the road. So everybody take care and have a great rest of your week. Bye now.
Thank you.
Thank you so much, everybody.